Perfect. So, hi everyone.
Hello.
First to answer first question before everybody's here. Who are we? My name is Quentin ADAM, and I'm leading a company called Clever Cloud. So we automate all the deployment stuff and application sustainability. Ping me on Twitter if you want to learn more about that. And this is my Paul.
And I am Steven Roux. I am an engineer, infrastructure engineer at OVH Cloud, which is a cloud provider.
Who already know OVH Cloud? Who already know Clever Cloud? Who is using both OVH and Clever Cloud? Okay, so we have work to do. Yeah, that's nice. Since we're on poll mode, who is knowing Kafka? Who is using Kafka? Knowing RabbitMQ? Using RabbitMQ?
MQTT? Oh, quite a bunch.
More question?
No, I think it's great. Just for that you get the picture, there is a full room knowing Kafka. So I think we are in the right room.
Yeah, I think we are in the right one. So we will talk about Apache Pulsar. What is Apache Pulsar, Steven?
Apache Pulsar is a new messaging solution. It's open source. It's an Apache project, and we will see on the slide after. It's an important part about packaging about Pulsar, but actually Pulsar doesn't come alone, because it's relying on different components. For example, Apache Bookkeeper, which is a sub-project inside Pulsar, and there is a Zookeeper also. Do you know Zookeeper?
Who is using Zookeeper? Maybe we can zoom a little bit about Bookkeeper. At the beginning, Bookkeeper was the distributed variety log. So variety log in any database, you have something we call the variety log. It's basically all the line of we have edit one data. And the line is in ordered mode, so you cannot shuffle the order of the variety log. And you have all the different change of the data in the wall. When you are in Postgres, you have the wall, and it's full written on only one host, because Postgres is built on only one node. When you're using something like Hadoop, for example, and you have the name node of the HDFS file system, you have a distributed variety log all around. At the beginning, Bookkeeper was this part of code excluded from the Apache Hadoop system, and with a very large rework to be re-included later.
Yeah, in the last third version of HDFS, you can bring Bookkeeper for name node replication. So Bookkeeper is a very important project, not very well known, but I think that it will start to get more and more use cases upon it.
It's a low-level distributed variety log. That can very big scale. We all use every day because basically Twitter Manhattan, which is the database with all the tweet, all the DM, all the retweet, everything, is based on Bookkeeper. There. Who have heard of Bookkeeper before? Yeah, just a few. It's a very interesting project, very clean code. It's part of everything in the Apache Foundation of we are cleaning the mess of old projects. And there is a lot of interesting new projects on the big data area coming from all these guys who are just cleaning the stuff. So where do the Apache Pulsar come from?
It came from Yahoo, which has many issues with messaging patterns, and it has been donated as open source software in 2026. It's running in production in Yahoo for many years now, so it's really production grade and really rock solid, actually.
Okay, so I have a good news for you. Apache Pulsar is very well packaged. It's one of the few projects of the Apache Foundation I have download, untar, execute, work. And I think I have downloaded the source code of Pulsar maybe 15 days after starting using it. For Apache project, it's kind of a performance. The documentation is good, the product is well packaged and works at the first time. It's a project which is really easy to start with, and there is a standalone mode. We start everything in a single JVM, so you can use it easily on your laptop if you want to try. So just hit that, and it will be working. Now we will explain you how it is built. And basically, Apache Pulsar is built on
layers. Actually, it's what is very interesting in Apache Pulsar because of the layered architecture. And we will see in the next slide that actually Pulsar is only focusing on the messaging pattern. So when you have the brokers, it is Pulsar. Under with the blue database, the bookie is actually the node name for Bookkeeper. Next, please. What's interesting here is that when you have a special layer for messaging with the messaging business, you can scale it, you can move it, you can kill a broker, spawn new brokers, and it's all stateless because actually there is no data in the broker. They are lying in the Bookkeeper layer, so it's all stateless. For those who use Kafka on a daily basis, I think I have a point when I say that you can just resize everything, and it's really nice at the operation layer.
One of the good, interesting stuff is Bookkeeper is evolving less quickly than the Pulsar stuff. So if you have new feature on the Pulsar broker, you just roll out new jar and starting it under on top of the Bookkeeper. So release new version of your entire cluster is way easy because the all data stuff is well packaged inside the Bookkeeper, and you can basically be less exigent with the way you use the upper level of bragging system. And that leads us to what is interesting stuff about Pulsar. It's a multimodal messaging platform. First, Pulsar have been built to be a distributed pub sub. But what it's been, Stephen, if you want to explain us that.
Yeah, before saying it's distributed, what actually is messaging? And under the underlying data structure to create a queue or a messaging solution is actually a log. So what's a log? A log stream, it's an ordered sequence of immutable records. So you get events, messages, records, and you store them orderly. It's really important, and we'll see next why. But it's distributed, so we have many different log streams. At this stage, it's really a matter of storage. But on the user stage, on the user perspective, each log stream is actually a partition. And if you're Kafka aware, it will talk to you with a single topic, many partitions, etc., etc. So there is a user visibility and the underlying storage constraint. Under the hood, each different topics is divided or not into partitions, but the special thing in Bookkeeper is that each partition is actually partitioned. So the basic unit of storage is not a partition, but it's a segment. And a segment is constrained in size or time, but when on Kafka, for example, you have the whole partition for a given topic. In Bookkeeper, you have a small unit, a smaller unit. So you can also spread it more easily or scale the storage layer, add new nodes, etc., etc.
Or maybe move the segment on another storage. Will be way more easy this way than have the storage on the same way. So what's happening is you get actually a writer log, which is distributed and non-blocking on ingress. So the path for writing inside the old Pulsar architecture give you the ability to get way more data inside, because you have you cannot block the ingress point of view because of this architecture of segments. I don't know if I am clear there, but it's very important to understand that if you write a lot in a topic, you will not block another topic, and you will not block the reading of another topic due to this architecture. We will maybe have more discussion about the reading pace later.
Yeah, sure. And since it's a distributed world, actually, you have this constraint to be very low latency. And we will see that Pulsar can bring you with I/O isolation, but it's another slide.
The architecture of Pulsar is very interesting if we are looking at an upper level. Basically, you have one jar, and the jar can be launched with several roles. And the role can be the broker. No, the broker is the basic stack, which is managing the message and everything. It can be a bookie, but it can also be the proxy. So basically, you can have everything on your Pulsar inside a network, and all the discussing with outside world will be handling with a proxy, which share the code of the protocol with the broker. So the proxy will be handling all the stuff. If maybe, for example, you have internal traffic where you want to be sure it's happening, you can have a pool of proxy. We speak with the broker. And you have outside traffic, which maybe can be faulty, maybe can be overload, maybe can be an attack. You can have another pool of proxy handling the traffic there and have quality of service. So the internal traffic will be guaranteed because your first pool of proxy, and the other pool of proxy will be not guaranteed because you maybe have a problem there. So it's one of the interesting stuff with the old Pulsar architecture. It has been built to push the communication to the outside world, to the proxy, and then have the broker managing the stuff. And there is two Zookeeper cluster. The first is Zookeeper for the internal stuff. It's the orange one on the schema, which manage the internal communication between the bookie and the broker and everything, which is a consensus stack error. And you have the green one, which is the outside Zookeeper for global clusters of cluster coordination. Because it's one of the big features, and we will speak about, of Pulsar, is the ability to manage multiple clusters at once.
You're spoiling my next slide, actually.
Yeah. It's the next slide? No, it's not the next slide.
No, not this one. You have many protocols, actually. Today, there is the Pulsar protocol. There is a WebSocket protocol. But things are moving. And currently, there is efforts to merge the Kafka protocols natively inside Pulsar. So this is kind of a big deal because actually Kafka now is not the technology anymore. It has quite evolved to be a specification, an ecosystem, and you will be able to integrate Pulsar with the entire Kafka ecosystem. And the proxy layer will bring you, for example, MQTT compatibility for you, for example, or HTTP, REST API, etc., etc. There is many things that can be done on the proxy layer.
Internally, the primary protocol of Pulsar is built on top of protocol buffer, so it's very easy to implement new client, and all the admin operations are done in HTTP. So there is no more speaking a binary protocol to do any admin operation, or there is no more a problem of doing some writing inside the Zookeeper, I don't know what, to create a topic, or I don't know what. Every administrative operation is handling on HTTP, and you can actually managing it with that. There is a CLI helping you to do that, and there is protobuf on the broker messaging level, and the WebSocket integration for the people who want to speak directly from the browser, for example. So, when we say distributed PubSub, First solution. So there is a two solution to manage some message in Pulsar. The first is you have a pub/sub like always. So basically, you put all your message. It's a distributed log, and you know in which message you are, and you commit this message, and you know where in the message list you are. It's the same thing that what you do with Kafka there when you commit the offset where you are reading. But there is also an interesting stuff, which is the queue system. If maybe you can explain.
Yeah,
that?
sure. What's a queue and the difference with a streaming solution? In a streaming solution, you will say, okay, I have consumed messages and I acknowledge up to this point. In Kafka, it's an offset. In Pulsar, it's a cursor. But you consume up to a point. But in a queue system, when you have, for example, a first task to be executed, if your consumer take it, but it's taking actually a long time, and your other consumer take a newest task to be dealt with. If it's an easy one and it gets done before, in the queue system you can say, okay, I acknowledge this task, and now I take another one. But the previous one is still ongoing. So you can acknowledge offset by offset, messages by messages. And it's a very big deal, because you can't do that in Kafka. Or you have to manage your offset by yourself. But here the really good feature is that it's all server-side. It's all integrated into Pulsar.
And you can have what you do with Kafka and streaming, and you can have the queue system you can do, for example, on RabbitMQ, which is acknowledging every messaging separately, and if a message is not acknowledged, remanaging it. So you can basically, on the same tool, have the both topology of messaging. Another thing is you have the ability to choose the delivery guarantee. What do you mean with that?
When we call about delivery guarantee, it's at most once, exactly once, or at least once. And there is a special thing with Pulsar to differentiate with others. They call the exactly once effectively once. And why it works with Pulsar, it's because there is a server-side deduplication. And the server-side deduplication makes your client agnostic about how to deal with exactly once semantic. In Kafka, for example, it's very intrusive into your code because you have to deal it on your side. Here, you just have to acknowledge, I can't process it for dead lettering. I mixed the two topics. But actually, there are different features on server side. Deduplication is one, and dead lettering, maybe you want to explain? I like your explanation about lettering.
The dead lettering is more like, if nobody enters that and it's not ACK, and if there is a problem, just put it in this box. It's another topic we will pull later with all the problem there. So you will never lose the actual information about everything there. To be honest, like creating, for example, speaking with a Pulsar is very simple. You have a client, you create a new producer, you say it's a string, you put something in topic, and then you send messages. And if you want to get some messages, so basically you create a new consumer, and you have a subscription, and you get the messaging, and you are in a forever loop, which is not very clean. So that's why there is a reader API help you doing that. So you're just taking all the messages by messages. Very simple.
If you come from Kafka, there is a thing that kind of be limiting in your use cases with the number of topics you have to handle. Because for each topic, there is a materialization of the storage with partitions, etc. So you can't really easily deal with many topics with Kafka. Here, the topic is really a logical entity because of the storage layer underlying, but it makes you create, for example, millions of topics. There is even some configuration tips to actually create millions of namespaces with millions of topics. So we are in a totally different scaling on the number of topics.
Who have already failed an entire Kafka cluster because someone decided to create 100,000 topics inside? Nobody failed a cluster this way? Very common way to fail. So this way, a good thing is you have no limit of the number of the topics you can use, which is giving back to the developer the ability to create or delete a topic. But more, you can listen multiple topics, which means that if you have some topics, like for example r.b, r.c, you can listen r.star, which is a catch-all. So you can have a regex on the topic you listen. So let's be clear about that. You have the consistency ordering on every topics. If you listen on multiple topics, there is no more consistency ordering. But it can be very useful for various use cases to be able to listen at multiple topics on just one subscription. This is one of the good features. The next one is the schema registry.
If you want to use type safety, for example, and your producer has to be aligned with what you can read on the other side, you can use a schema registry. So there is different kind of utilization. So you can push a new version with your producer, or you can get the schema and push messages. And it will enforce that the consumer can actually read messages that are pushed on the topic. So it's basically the same as Kafka if you're comfortable with it.
And basically, the schema registry is built on top of Apache Avro, which is, once again, the ability of this project to reuse piece of technology of the Apache Foundation. So you have a very simple stuff. We'll give you the schema of the data you put in a schema, in the registry. So every data you put on the stuff is OK. And then you will have the ability on every topic to decide how to handle that. Do I support backward compatibility? Do I say if you try to push an old message, I will not take it? If you try to read an old message, you cannot make it? Or maybe you can read an old message because there is only one add on the system. So it's very interesting because you actually can address also the problem of managing the data on top of the Pulsar system with the schema registry, exactly like the database. So very practical. If we want to talk about the write path.
Yeah, we are missing a slide here, but globally we are talking about one feature which is I/O isolation and access patterns. When we speak about access patterns in messaging solutions, there are three kinds of access patterns. You have writes, for sure. You have tailing reads, reading in real time, and catch-up reads. Okay, I need to read a month of events or the year of events, etc. So we will see here why we have an I/O isolation. First, for tailing reads, you don't get to storage layer because it's Pulsar that caches messages and that will serve directly. But for writes, you can go on. Writes go through the journal, like the wall, for example. Once written in the wall, you populate the write cache, and you acknowledge the write. Once it's done, you will flush your entry logs, but it's an asynchronous process. This explains why also writes are very performant on bookkeepers. And you populate the read cache with the index or where are the actual entry logs. On reads, when you read the tailing reads, actually it's a Pulsar, but if you are in a catch-up read mode, you will hit the write cache, and if your data is not there, you will get to the read cache and go to the entry log if it's not there anymore. So there are different logic and different isolation in buffering and cache that make it perform very, very well.
And one of the interesting stuff is you can actually choose all the strategy you want. You can have persistent or non-persistent message on top of Pulsar. So the non-persistent is a little bit like UDP, but for messaging. So it's very interesting because it goes very fast. So you have a very low latency when you're using this. And you can be non-persistent and you can be persistent. So that means if, for example, you have some of the messages which are important to store, you will store it, but you can have many brokers managing a lot of non-persistent messages and just have a few with a storage system, which is, one time again, the interest of decoupling the storage of the broking system. The other part is a compacted system. What is a compacted topic, Steven?
Compacted topic is a topic where when you push a message, you use a key. And at compaction time, Pulsar will only keep the last key, the last message per key. So if you want an example, we can imagine with stocks, for example. You are consuming all updates on stocks. For example, Amazon, Google, not yet OVH actually, but Criteo, any. And you have many, many versions, actually, because there are updates on each stock. But the compaction will keep only the last one. So if you have a worker that pop and consume the entire topic, he will get only the last one. It can be very useful in many, many different use cases.
Compacted topics is very useful because you can store all the data in a non-compacted topics and use this as analytics, and use the compacted topics as a representation to boot when you start a new worker. So basically the compacted topics is a way to create quickly a snapshot, and the full version will be the ability to read all the word. And with the compaction, well, there is another thing, which is the deduplication of the content of the message, which is also provided by Pulsar.
Just a word on non-persistency. Because of the layered model and because we can read in a non-persistent fashion some topics, if you have a use case that is true real-time, you don't need any overhead with latency to store any message. So actually, in this mode, you will get lower latency. So for pure real-time use case, it's a very, very good feature.
So, message retention and policy.
So there is a lot of ways to manage your retention. First, there is a difference between messages that have been acknowledged or not. If a message has been acknowledged, there is a retention policy. For example, you say, I want to keep my messages for 1 month, and after they will be deleted. So the green retention policy is this window. And if you don't have read any message, they are stuck, they are kept forever, but you can also put a setting so that I want to keep my messages, for example, for a weekend. But if I go further a weekend, messages are not yet, they don't have any interest. I don't want to keep them. So I put a TTL on this topic so that messages after maybe, for example, 2 days will be deleted. So you can really do what you want with messages retention on Pulsar, and it's really, really interesting.
And when we're speaking about the messaging retention and expiration, there is a very interesting stuff in Pulsar is every time you write something or consume something, the action of actually writing or consuming is an action store the data itself. So if you write something, you will have the reader ID, which is filled. Or if you consume a message, you will have the consumption will be at this time by this consumption ID. At Clever Cloud, what we do is we put on the consumption and reader ID the software, we build it, but also the commit ID of the stuff and the instance ID of the stuff. So if we know, for example, there is a commit which is a corrupting message, we can easily select every message with this kind of stuff, which is an interesting layer on top of the ability to consume, which is who have done what and when, to be sure that we can revert any action on the policy there. The next feature we very love is the tiering storage. Your Kafka glosser is growing and growing and growing, and you have a lot of data there you never access. But it's still on your expensive SSD, replicated many times and stuff, but you never access it. With Pulsar, you can say, OK, we will tire the storage at some times to another place. So you will be able to store on any object storage like S3 protocol, like the OpenStack protocol, the Google one, the Azure one, like all the file system, all the messaging using, it's using another project from Apache Foundation which is called gcloud, which has a very cool logo, if you want my opinion on this. And what's happening is you will be able to access all your message. So the message is still there, it's just slow because it's on the object storage. And it's mainly HTTP on slow I/O, so it will be slow. But if you want to consume an entire topic which have been tiring, it will be OK. You can grab all the data from there. So it's allow you to have a small bookkeeper and a lot of storage for your cold storage on the messaging platform.
And it can be very useful, for example, for audit log. You have legally to keep them, so maybe for a year or 5 years or whatever. But as Quentin said, you can keep your bookkeeper cluster with a reasonable size if you need. But you can also have 1 year in bookkeeper if you decide.
OK, security. Security first feature is a proxy. Because using the proxy will be able to have a very clean way to access your cluster. It will be very easy to design the network to access the cluster. Then you have the multi-tenancy. Basically, every topic in Pulsar is designed with, you have a tenant, you have a namespace, then you have a topic, ///. What is interesting about that is, by design, the thing is able to manage multiple users which actually don't know each other. It's multi-tenant from the beginning. And more, you have pluggable auth. Pulsar comes with JWT, it comes with basic auth, comes with CQRS, but it's very easy to add a new plugin for authentication inside Pulsar. And as at Clever Cloud, we are building the new one. I'm very pleased to announce you that we will be providing the biscuit.
What's a biscuit? Can you?
OK, I will explain what is a biscuit. Biscuit is a new token for access. It's designed with protocol buffer at the beginning, so it's a small token. And it allows you to do something very nice, which is called attenuation. Attenuation is the ability to say, if I have a biscuit, I can craft a biscuit which will have the same right or less right than my biscuit and give it to Steven. And Steven will be able to access the system with this. It's kind of the stuff the macaroon can do, but it's better because there is no shared secret. And there is a language inside it called datalog, which gives you access to actually check the right. So all the biscuit specs and implementation are open source. And it's a new stuff we're pushing, which is a very clean way to manage the access on your different software. Because it's small, decentralized, attenuation aware, and know the right and not the identity. Because in JWT, you say, Robert is an admin. So every time you get a JWT, you say, oh, Robert is an admin. So he's allowed to do that. But what we do with Biscuit is managing in the data log the ability to say, Robert is able to do that. So if you look at the data log, you will be able to say that. So ping me on Twitter if you want more information about that. But the biscuit will be integrated in Pulsar in just like a few weeks.
What's important is if you have a IAM, for example, any IAM solution, you can integrate Pulsar in this IAM with your custom system, Biscuit being one of them, for example.
Or Otens also is
Otens is an IAM from Yahoo also, and it's natively integrated into Pulsar.
Very simple to write a custom plugin out. So, the multi-cluster management.
Quentin, in the early stages of the show, told that there is an internal Zookeeper cluster, but there is also a configuration store today implemented with an external Zookeeper cluster. If we simplify, next slide please, if we simplify the view of a cluster, what do we have? We have brokers, we have bookies, internal Zookeeper, and this external Zookeeper. Why it's really interesting is that if you have a regionalized cluster or multiple cluster given the logical, the physical replication you want, this Zookeeper is actually crossing every cluster, so that the management will be unified. You can take any cluster and create a topic, global topics, for example. So if you need, no, please, previous one, I forgot the discovery component.
Oh, yeah.
So what's the discovery, no, this one. Yeah, what's the discovery component? You could provide to your customers a single URL with any cluster behind. And the discovery will say, okay, for this topic, the right cluster is this one. So you can actually mask all the complexity, all the replication, all the number of cluster you have behind, and you provide a single URL to your customer. So it's really nice.
And one of the great things is you can say that this tenant has access to this and this cluster. And this tenant has access to this and this cluster. So you can dedicate a cluster for a tenant at a point and migrate, for example, all the workload of a tenant, which can be noisy, for example, into one cluster in your multiple cluster system on top of Pulsar.
And because every cluster actually knows every other, you can enable geo-replication between clusters. So if you have a topic in, for example, EU FR1, another in the US or another in Germany, for example, you can just say, okay, now this topic is enabled globally. And it just works. You just have geo-replication inside Apache Pulsar. For those who have worked with Mirror Maker, for example, it's kind of a relief, really.
Pulsar is very well integrated with all the ecosystem of Apache and other stuff. So I give you just a few logos here of the project. You maybe know Fling, Skywalking, or WCM, which is a really great project, which are used by a lot of people, but also a lot of name of something we call Pulsar.io, which is all the integration. Like, for example, you can have all the data source from a Redis or a RabbitMQ, or coming from a MySQL data, because you can pull all the replication event of a MySQL, for example, to replicate inside your cluster. You can push all the data to Rabbit. So it's very easy to integrate Pulsar using the Pulsar IO inside another thing. And another interesting stuff I want to zoom in is the SQL integration. Who know Presto? Okay. Now, maybe we will talk a little bit about that. Presto is a SQL query planner you can use on multiple databases. Like, for example, you can have a join between a PostgreSQL and a Mongo. So there is no indexes. It's only built for making requests on large, very, very complex combination of data repository. And in one SQL, be able to touch everything. Presto has a very big integration with Pulsar, giving you the access to actually talk to the bookkeeper. So when you're using the Presto integration, you're not talking to many brokers or stuff like that. You're directly speaking to the bookkeeper or the cloud storage of the G-Cloud, making you able to do something impressive, which is using a topic as a SQL table, which is very, very useful. All your message will be there. This is using the schema registry. Because if you want to be able to request all the stuff, you need to have the registry, the schema registry of the tuple. Very practical. And impressive because it's scalable, it's part.
Yeah, and because Presto access directly to the bookkeeper layer, it doesn't put any pressure on the broker layer. So your real-time use cases doesn't suffer on analytics queries like with Presto, for example.
Very nice. Another interesting stuff is the function. Basically, Pulsar integrates the way of have a data processing inside the Pulsar system. So you have topics, you have message in the topics, you can push it in a Pulsar function, and the Pulsar function can push the data to another topic after a treatment, for example, or push some logs to a log topic, which can be interesting to maybe have an error management or I don't know what. Pulsar function is very easy to use. You just create a Pulsar function, and you can say what's the delivery you want. And once again, it's the Pulsar flexibility is interesting there, because it can be the function will be executed one time per message, effectively once per message, or maybe one time per message. So it's very interesting to be able in which function to know if it will be a contention plan or not a contention point. And the function can be executed in a threaded mode. So you have another worker in the jar, the big jar of Pulsar. You can launch another worker, which is the function workload, which will be able in a thread to launch a Java function, which is really easy to do. But you launch a new Java function inside the thread. You have the process one, which launch new process for every function. More slow, more easy, but you can write Java, or you can write Python, you can write Golang, nearly, to do that. And there is also a Kubernetes integration to launch function, but to be honest, this seems to me a very bad idea, and there is Bitdragon, I never use that, but there is a Kubernetes integration, so we are cloud native there, okay? And more, because it's very easy to integrate a new implementation of the function model. So a sneak preview of what we are building inside the Clever Cloud. We are building a new serverless system. We will basically allow you to use the Pulsar function with WebAssembly. So you write the code from Rust, TypeScript, Kotlin, Golang, C++, C if you want, or even Haskell. Okay, I don't know. And all function is executed inside its own virtual machine. We start just a unikernel in a few nanoseconds, launch your function, and give back the answer. So you have the isolation of a virtual machine and the ability to use serverless stuff. It will be ready on Clever Cloud like very soon. I do the first demo next week, so I hope it will be ready. Operating. Yeah,
what's also nice, it's that first, we said for admin you have the REST API, but it's not only for admin. You have also metrics. You have a custom integrated load balancer, so that if a broker is kind of loaded, Pulsar will automatically split the load onto multiple brokers and say, okay, this topic, I will move it on other, etc. And because it's stateless, it's just a matter of a switch. So it's nice.
And more, client. How can we talk with Pulsar? First of all, there is a Java client, and with the Java client, you have also all the Scala and Akka integration, which is important for me. So I think there is various integration in the JVM to have a very nice integration of Pulsar inside your framework, and not only the client, but also multiple integration inside what you need. There is a C++ client, which is official client. There is a Node client. I didn't write the Node client there, but there is a Node client. There is a Rust client, obviously, because of Clever Cloud. There is a Go client. In fact, there is two Go clients. There is the one which is a binding to the C++, and the one which is full news. The full in Go is not totally ready. I don't know. It's writing. It's not consuming. It is.
No. There is a full Golang. Okay. I found the new official one actually.
Okay. The Pulsar community is working very well. There is Python, and there is the logo. Nobody knows is WebSocket. So you have the ability to speak with the WebSocket with someone who don't know that. Basically, the client is very simple to do because it's protocol buffer and HTTP. So it's very simple to have a new client there. And we have to say the community is very helpful. There is a Slack, open source project in this year, Slack. So there is Slack, which is very friendly. And something interesting about the management of the project?
Yeah, because actually Pulsar is the first Apache project that is first in GitHub. It's not a GitHub mirror. It's the first time for an Apache product, right?
Yeah. And yeah, very, very full community. It's the beginning of the community where everyone know each other, so it's building great. It's very friendly community. It's very nice to be there. So I hope this presentation was helpful to you. Thank you very much for listening.
And you have 4 minutes left for questions, if you have.
Thank you.
Thank you.
I have some pen of Clever Cloud with a screwdriver inside, and I have some cool stickers and everything if you want some swag. And we're open for questions. We have some questions. We were too precise? No question?
Who wants to test?
What about the integration with other agents to pass logs and stuff like that?
So the question is, what are the integration with stuff like Logstash or any other agent? There is an integration with Logstash, which is built. There is a Kafka API on Java, which is just swapping, an artifact in your Maven, which have been built, and it's working for Logstash because we're using it in production right now. I'm pretty sure there is also other integration because it's very easy to do, but don't know. Maybe Beamium?
And you also have Debezium, actually, that makes the glue between any source to Pulsar sync. So. Yeah?
Yeah, we have a lot of GMS legacy. Any plans on the GMS connector thing?
To get some metrics?
No, to get messages in.
Oh, GMS. Okay, sorry.
I don't know if there is a Pulsar I/O integration for GMS.
I'm not sure.
I don't think. I think it will not be very complicated to implement a GMS connector. I'm pretty sure it's already a topic for many people in the Pulsar community. So maybe you can jump on the Slack and ask the question, because I'm pretty sure, I'm pretty sure it's something happening. There is another question.
Pulsar seems to address some weaknesses of Kafka. Would you already use it in a production installation?
Yes, we're using it in a production installation, both at OVH and Clever Cloud, and we're using also Kafka. We're not replacing all the Kafka with Pulsar right now, and I think I process more message using Kafka than Pulsar right now. But yes, we're using it at production at a larger number of thousands messages per second. So we're pretty happy from there. I don't know if you can maybe...
Yeah, we're also really happy with Kafka. Actually, Kafka is a very great piece of technology. It's a great software, great community, and very, very large ecosystem. There are use cases where Kafka is not actually the ideal solution. So here is Pulsar. Where do we use Pulsar? We actually built a new product on OVH, which is called IOStream. And since we can easily control the number of topics that will be created by customers because it's their decision. We rely on Pulsar because it's very, very more flexible for us. So it's globally managed Pulsar if you get it.
It's more easy for building local solution on top of a messaging system. So yes, last question, and after we will close there.
Transactional streaming, when is ready?
Sorry?
Transactional streaming, when is ready?
There is transaction.
Yeah, transactions are just coming for the next release, which will be the 2.5.0. They're working, so it's just coming into the coming release. But it's used in production by, namely, Tencent for its billing system. So since it's a billing system, you touch the money, so you have to work, and you have to be low latency and transactional. So it's basically working, but it's not in the public release right now. It's just in the coming one.
Okay, thank you very much all, and come here if you want to some swag.
Thank you.
Thanks.